Today we're going to be dealing with solving systems by elimination for the second day. Remember, for these things we want to make sure that our variables are lined up, the numbers are lined up, and then we want to make sure that we have the same coefficient, one positive and one negative, for either the x's or the y's, so that we can work on eliminating that variable. After that, we're going to solve, get one variable, and then plug that back in to one of the original equations and substitute in to get the second variable. So with this, we're looking first, we have 2x plus 5y equals -1 and x plus 2y equals 0. And here the x's don't have the same number and the y's don't have the same number. And it's not easy for us just to multiply by -1 like we did the other day. So here we want to know, can we take this number 1 that's in front of this x and easily get to that 2? And yes, we can. It means that we're going to multiply this bottom equation by 2. Now, if we just multiply by a positive 2, that's not going to make these be the opposite signs. So that means that we're going to make this be a -2. And I'm choosing the x's because 1 multiplies to get 2 a lot easier than 2 multiplies to get 5. So the first equation is staying the same, so we're going to write it down exactly as it was. And the second equation, when we distribute this this -2, it's going to give us -2x minus 4y equals 0. So we have to remember that we need to distribute it to everything. Alright, so now that we're here, we're going to add our equations together. 2x plus a -2x, those eliminate. That's what we want to happen here. 5y plus -4y is 1y or just y. And -1 plus 0 is a -1. So just like that, we have what y equals. And so now we're going to take that information and plug it back into one of the original equations. It doesn't matter if you choose the top one or the bottom one, but we're going to substitute back in. So let's choose the top one. So we have 2x plus 5 times our y value is a -1 equals -1. Working on this, we have 2x minus 5 equals -1. So we will add 5 to both sides. And 2x will equal 4. Dividing by 2, we get x equals +2. And the last step to take is just to write our answer as x comma y. So we got x to be 2 and y to be -1. So 2, -1 is our solution. We can take that and we can plug it into the calculator to see what it looks like graphed, or we can plug the numbers in, but it does work in both equations. So that is our solution. Okay, let's look at this one. We have 3x plus 6y equals 6, and 2x minus 3y equals 4. So again, we're looking, everything's lined up, we're good to go there. The next thing is to see if we're going to want to eliminate the x's or the y's. So we're going to start with a smaller coefficient. So does 2 easily multiply by something to get to 3? Not easily enough. So let's look at the y's before we decide. So we have -3 to get to 6. To get from 3 to 6, that's really easy to multiply this bottom equation by a +2. I'm already going to have one positive and one negative there, so this just needs to be a +2. The first equation stays the same. And the second equation, when we distribute in, would give us 4x minus 6y equals 8. So we're going to add those equations together and get 7x, the y's eliminate, equals 14. Dividing by 7 on both sides, x would equal 2. Now we're going to take that answer and substitute it back into one of the original equations. So I'm going to choose the top equation again. So we have 3, we got 2 for our x value, plus 6y equals 6. So we're substituting that value in. That means that we would have 6 plus 6y equals 6. So subtracting 6 on both sides, we get 6y equals 0. And still dividing, y is going to equal 0. So that gives us an answer of 2, 0. And again, plug this into the calculator or plug in the numbers and it will work with both equations. A solution has to work with both equations in a system. All right, so we need to work on now solving this system. So we have 2x minus 3y equals negative 11 and 3x plus 2y equals 29. So here we're looking, everything's lined up. We're great there. 2 doesn't easily multiply to get 3, and 2 doesn't easily multiply to get 3 there either. So what that means is we can't just multiply one equation by something, we have to multiply both equations by something in order to make the coefficients of either the x's or the y's be the same. So I notice here that both of these numbers are positive. Here for the y's, our coefficients, we have one positive and one negative. So that means that I'm going to want to eliminate my y's. Now it really doesn't matter. You could choose to eliminate the x's in this case. You just have to be careful with it. But if I want the y's to have the same coefficient, I'm going to multiply the top equation by 2 and the bottom equation by a positive 3. That's going to make both of the coefficients of the y's be 6. Okay, one would be positive 6 and one would be the negative 6, and that's going to make them eliminate. So here we're going to distribute, and we would get 4x minus 6y equals negative 22. And for the second equation, we get 9x plus 6y equals 29 times 3 would give us 87. So then we're going to add those equations together, and that gives us 13x. The y's eliminate, and we get 65. So we're going to divide both sides by 13, and x would equal 5. Once we have that information, we're going to take that and plug it back into one of the original equations. So let's plug that into the bottom equation this time. So we have 3 times 5 plus 2y equals 29. That means we have 15 plus 2y equals 29. So subtracting 15 on both sides, we get 2y equals 14, or y equals 7. So 5, 7 will then be our solution, because x should come first and y should come second. Okay? Alright, last set here. So we have 4x minus 3y equals 11, and 3x minus 5y equals negative 11. And we're trying to work on using elimination here. So we need the same number with our x's or our y's, because everything's lined up, so that looks good. 3 doesn't easily multiply to give us 4, and 3 doesn't easily multiply to give us 5. So we have to decide if we want to eliminate the x's or the y's here. So let's work on eliminating the x's this time. So if I want the 3 and the 4 to have the same coefficient, I'm going to bring this 3 up top here and the 4 down here. Now if I leave it just like that, both of these are going to be a positive 12x when we multiply them. So we need to make one of them be negative. It does not matter which one you make negative, you just need to make one of them negative. So let's distribute this in. That would give us negative 12x plus 9y equals negative 33, and 12x minus 20y equals a negative 44. Remember that number out front needs to get multiplied to everything. So now we're adding our equations together. Here the x's eliminate, because negative 12 and positive 12 are opposites of each other. 9y plus a negative 20y is negative 11y. And negative 33 plus a negative 44 is a negative 77. So dividing both sides, we get y equals positive 7. And now we're going to take that and plug that back into one of the original equations. So we'll plug into the top equations. We have 4x minus 3 times, we just got positive 7. So 4x minus 21 equals 11. Adding 21 to both sides, we get 4x equals 32. And dividing by 4, x would equal 8. That means that our final answer would be the 0.87. Okay, so make sure you're going to have the same coefficient, one positive and one negative, with either the x's or the y's, that they are going to eliminate before you move forward with this process.